In the last video, we saw that transformers are used to change the potential difference of an electricity supply, with step-up transformers increasing the potential difference because they have more turns on the secondary coil than on the primary coil, and step-down transformers decreasing the potential difference because they have fewer turns on the secondary coil. In this video, however, we're going to cover how to use two important equations which together allow us to figure out exactly how the potential difference and the current vary with the number of turns on each coil. In both equations, the letter V stands for the potential difference, N stands for the number of turns on the coil, and I represents the current. Additionally, the little p and s letters refer to the primary and secondary coils respectively. So, for example, V sub p means the input potential difference across the primary coil, while N sub s means the number of turns on the secondary coil. To see how these equations work, let us try a few example questions. First, consider a transformer that has 18 turns on its primary coil, 54 turns on its secondary coil, and an input potential difference of 45 volts. We are asked to calculate the output potential difference. When solving these kinds of questions, it is best to make a clear list of what you know and what you are trying to find out. Here, we know that N sub p, which is the number of turns on the primary coil, is 18, N sub s is 54, and V sub p is 45 volts. What we need to find is V sub s, the output potential difference, so we can represent it with a question mark. Looking at our two equations, it is clear that we will need to use the first one because we do not have any current values, so the second equation is not applicable here. Plugging in the values we know, the equation becomes 45 divided by V sub s equals 18 divided by 54. Simplifying 18 over 54 gives us 0.33. We can then rearrange the equation to isolate V sub s and use a calculator to find that V sub s must be 135 volts. Therefore, the output potential difference is 135 volts. Now, let us move on to the second example, where we calculate the output current using the same transformer. We are told that the input current I sub p is 12 amps and we need to find I sub s, the output current. This time, we have to use the second equation. Plugging in the known values, the equation is 45 times 12 equals 135 times I sub s. Next, we divide both sides by 135 to isolate I sub s, resulting in 45 times 12 divided by 135 equals I sub s. Using a calculator to evaluate this expression gives us 4 equals I sub s. Hence, the output current is 4 amps. And that is everything for this video. I hope you found this explanation helpful, and I will see you again soon. If you want me to tweak it more, just say.